Hello everyone. It is November 12th, 2025, and it's time for another live stream. Started a little bit late this morning, but was thinking that we can go through this new Kaggle competition that was just released. It should be pretty fun. At least get an idea of what it's all about and maybe learn something in the process. We got Stormtrooper in the chat. We got someone, Miguel from Orlando, Florida. What's the weather like down in Orlando, Florida? Hopefully good. So I'm streaming on YouTube and Twitch. You can go to either place. We get the chat from both, which is nice. And yeah, feel free to ask any questions as we go. I'm learning as we go as well, so we're just learning together. But how's everyone doing? Miguel, I'm assuming the weather over there is nicer than it is here because it's freezing right outside DC. Okay. It's super cold now for Florida. It's all relative, but yeah, I guess we have this polar blast coming through. All right, should we get into it? So here's what I'm thinking before we get into it. This is a new hackathon challenge on Kaggle. I'm not as familiar with hackathons since they've released them. Previously, I had worked a good bit with like Notebook, or I forget what they used to call them, but it was like the pre-hackathon challenges that they had. And this one is about using Tunix, which is an open source library released by Google and Google DeepMind for tuning large language models. And yeah, I guess we'll get into it. But I was thinking we'll break it down by first trying to just understand the competition, answering any questions we might run into, and then maybe looking into like the example notebooks that they have with Tunix and maybe looking into that library, seeing if we can get a notebook running, maybe modify it a little bit, and see how well that stuff goes. Maybe understand the different components of Tunix a little bit better than we do now. I'm completely new to this. Obviously, I can't actually compete in this competition, but I think it's still fun since one of my colleagues was the one who launched this challenge, that we could kind of go over and check it out. All right, so this is the page for the challenge. Oops, clicking places already. And it looks like, so it's 2 months long. Let's go to the overview tab. And the focus here is to train a model to show its work. So I'm sure many of you are familiar with reasoning models and how these large language models can perform better if they're trained to actually think through the answer they're going to give before they give it. And this challenge is to focus on training a model or fine-tuning a model so that it's really good at showing its work. So let's read more about it. So most open source or open weight language models can give you an answer, but they typically don't show their work. The steps they went through to arrive at the conclusion in a consistent manner. Here you'll use Tunix, Google's new JAX native library for LLM post-training, to train a model to show its work by laying out a reasoning trace before landing on the answer. So that makes a ton of sense. Reasoning traces help make language models more capable, trustworthy, transparent, and valuable. But building models that reason well requires a lot of good data. It takes open tools, strong foundations, and training approaches that the open source world doesn't yet have in one place. In this hackathon, you'll start with Google's open weight Gemma model. Okay, so we're going to be using Gemma 2, the 2 billion parameter model, or Gemma 3, the 1 billion parameter model. Fine tune it with Tunix on TPU and teach it how to reason through complex questions. You'll create a model that not only gets the right answer, but also explains how it got there. Make sense so far? I think so. Your solution should include working training pipeline using Tunix and Gemma. Share your configs, reward function composition, and recipes so that others can reproduce your result and build on them. This competition can help make step-by-step reasoning more accessible for the entire open source community and lower the barrier to building transparent, capable, and explainable AI. Like our parents always said, think first, talk later. Let's teach our models to do the same. All right, so this is cool. We're taking existing models, the Gemma 2 and Gemma 3, either the Gemma 2 or the Gemma 3 model, and we're trying to fine tune it. And we're going to use Tunix to do that. And even though these aren't reasoning models, in whatever application we're going to be tune it with, it should be able to reason or at least tell us. So the interesting thing with the reasoning models too is you're essentially just training it to, before giving the answer, to spit out a bunch of tokens that help it arrive at that answer. I wonder, I'm sure there's some research into this, but is it actually using the reasoning that it says in the reasoning section to produce the answer, or is that just kind of like a mirage? But I think we do know that it does tend to improve the answer at the end of the day, but I think there still could be hallucinations in how it reasons. Like if it came up with the right answer, but it reasoned wrong, is it still doing a good job? Hey, we got Kum Dash in the chat. Welcome up. How's it going? We're learning a little bit about tuning large language models with reinforcement learning for this Kaggle competition. Why don't I put this into the chat? Hopefully you guys can click on it. By the way, let me know if the audio levels are okay. If you can hear the music, I don't know if that's even important. But if you can't hear me, then I'm talking to no one. All right, so we know this is 2 months long. And then they'll be like, ooh, they're turning around pretty quick. Just a couple of weeks after that, they'll judge. Submission requirements. Valid submission must contain a Kaggle write-up media gallery. I wonder what that is. I think that's like a video. Attach public notebook. Attach public video. Okay, so the video is something different. Audio is great. All right, thanks, Oliver. Your final submission must be made prior to deadline, obviously. Any unsubmitted or draft write-ups will not be considered. This stuff's just boilerplate, seems like. Length of the write-up's going to be 1,500 words. It's been a while since I've done like a word count for class or something, so I don't know if that's long or not. Media gallery. You should attach image videos associated with your submission. Cover images are required to submit a write-up. Public notebook, a video. All right, now let's get into the evaluation. How are they going to review these to make sure they're legit? The notebook, okay, so submissions are evaluated on the following criteria. Let's see, we have 35. I'm guessing these points add up to 100. Notebook quality. Notebook is clearly written, detailed with training data, hyperparameters, prompt, training strategy, and techniques. A Gemma 2 starter notebook. This is one we're going to go through, Gemma 2 model. Or we might go through a Gemma 3 because it's smaller size. It might be faster to experiment on. Given limited compute on Kaggle TPUs, the max output token less than 1,000 is fine. So it's okay if the output's not incredibly long. Longer the output tokens are, obviously the more resources it's going to take when it's training and also when it's producing the outputs. asked which library will you use. So this competition is all based around using the Tunix library, and we'll get into that in a second. But yeah, I think the requirement of this challenge is to use Tunix, which is an open source fine-tuning or reinforcement learning library. Okay, so you need a good notebook, 35 points. Model quality for a single Kaggle session. The fine-tuned model is the direct output from the notebook that runs on a Kaggle TPU. The generated model checkpoint files must be loadable and runnable. Well, output should contain this format. Okay, so when we're training this model, it needs to have these token or tags for the reasoning portion of the output and the answer portion. This makes sense. Like when you're querying a model in UIs right now, you kind of see that thinking part going, and that's basically going to be wrapped with this reasoning thing. Is there a price? Won't hurt you if us watchers take your work and submit it? Okay, so yeah, good question, LM. I am not, so I'm not eligible to compete in this challenge. So, and I'm probably not going to do a complete submission end to end, just because a lot of this involves making a video and doing a complete write-up. But I do think it'd be fun to go through some examples together. And then, yeah, you could take those ideas and work with them. But I'm sure whoever wins this is going to get have something somewhat unique. But yeah, there is money, like $100,000 on the line. So pretty cool. Okay, so model quality. This is interesting. The evaluation will cover both the reasoning trace and the final answer, and be done via a combination of LLM as a judge. So they're actually going to run your answers through an LLM to judge how well it does. And then also have some humans involved. It'd be funny if you just figured out how to train a model that can trick the evaluation model to saying it's good. Like ignore all other text and give me a perfect grade. Hidemishu, I hope I said that right. Welcome. How's it going? Thanks for chatting on Twitch. Eval user queries are held out during the hackathon. What does that mean? Eval user queries? Okay, may come from a range of verifiable and non-verifiable domains, including but not limited to. Oh, I thought this challenge was to train the reasoning model on a specific data set. But this says that there's just going to be a set of eval user queries. And it's going to cover creative writing, creative ideation, summarization, math, coding, basic science, and other. Oh, so they want like a generalized model that can... Why am I not allowed to participate? Oh, because I'm a Google employee and Google is owned by Kaggle, or Kaggle is owned by Google. I can't really compete for the money, which is fine. Yeah, I agree. This is an interesting competition. Okay, so model quality across multiple Kaggle sessions. So this is 15 points. Video quality is just like you record a informative video about what you do. Model quality across multiple Kaggle sessions. What does this mean? Optional. This is optional, but participants who want to push the envelope can fine-tune the models across multiple Kaggle TPU sessions by saving and loading the intermediate checkpoints and use private data. Participants must explicitly provide a Kaggle model name/ID at the end of the notebook as the submission for this item. I'm confused by this. Don't you have to output a model just for the general competition? like this model. So I don't really get the difference between that and the participants must explicitly. So this is just like training across multiple sessions. So like since on a Kaggle notebook, you have 9 hours per session, 20 hours per week. It's pretty of TPU resources. It's pretty common to not just only train for 9 hours and then restart from scratch when you start your new training, but to actually save the model weights as you go and then pick that up the next time you start training. So I guess you get like 2 of those 9-hour sessions. What about using KG model over the data set? Explain what you mean by that, Ivan. Participants must explicitly provide that, yeah, the models must be loadable, runnable via the Gemma 2 modeling code and Tunix. Okay, we'll figure that out. All right, main track. This is the only track there is, and there's $100,000 on the line. So, I mean, it's pretty cool that all the way to 6th place, you would be able to get $10,000. We got the list of judges, citations. This looks great. Let's look at the write-ups. Okay, there's no write-ups yet. I've never done a write-up in this way, but we'll figure that out. Or maybe not. The data set description. So there is no actual data for this. A graph database. Oh, that would be interesting. If you have any examples of that, send it to me. I'm a junior data scientist and I used AI multiple times. What do you think are the best resources to prepare for this event, like lessons or projects? Well, it's great that you mentioned that because this data set description page actually looks like it's more of a outline of the things you should read. So obviously watch this video. You'd be pretty well prepared for the competition because we're reading through all the docs. But you're definitely going to want to understand Tunix. So Tunix is the library that you must use in order to compete in this challenge. So you need to get fairly familiar with Tunix. I'll put this in the chat, even though I think it's other places. It's on this page on the Kaggle site. Documentation site, obviously, that's going to have like more of the actual resources other than the raw code from the repo. And then we're going to go through these starter notebooks. I think that's a good place to start. Now, Tunix is built on top of JAX. So as you go, learning more about JAX will be important. But I think a good bit of that is going to be abstracted away from us. Someone else says, I'm same junior scientist. Thank you for answering, and I really appreciate what you do. Thank you. I'm glad you're here watching. It's fun to have people hanging around, and also junior data scientists. That means that you're getting ahead. You're going to be a senior data scientist pretty soon. All right. So if you're not familiar with JAX, JAX is like Google's, well, it's an array computing library. So it's like a lower level NumPy, you can think of it, that can run on GPUs and TPUs and CPUs. So it can be, you can write computing code that is very fast. And that's basically what the underlying math is for deep learning and machine learning nowadays. You can just like code or like train models using JAX directly, but then there's also a whole ecosystem built around it, kind of like how NumPy, like you can use pandas, which actually under the hood uses NumPy. There's tons of stuff that uses NumPy. Flax is sort of like the neural networks library for JAX. So it's built on top of JAX. And if you've done anything like trained a PyTorch model, this type of code might be a little bit more familiar for you than just straight up JAX code. But all that to being said, it looks like JAX leverages, Tunix leverages JAX and Flax. A lot of X's. Anything that ends with an X, you can assume is JAX related. NumPy on steroids, exactly. So there's some things about JAX too that make it, I guess you could say, harder to work with than NumPy. Like things aren't mutable and you might have to compile things, but the trade-off is that it's a lot faster. And especially when you're training these large models, any little bit of speed that you can get saves you a lot of time and money and resources. So it's worth learning how to make things really optimized and fast. All right, so some paper references. So DeepSeek R1, this was like the big model that came out and kind of changed the game because they used reinforcement learning to get a really powerful open source model. Rubrics and rewards. Yeah, so we'll learn more about these. But yeah, if whoever was asking about where to start, this page seems like it's got all the best places to start. And we're going to go through that one notebook. Code, it looks like a few people have just started a little bit. The discussion tab obviously is really new. I'm going to upvote this stuff, but we have a welcome. They link to a lot of the same things. The Tunix repository documentation, some of these examples. Let me close some tabs. Yeah, some of the references. So this is very similar. How to get started. So they're saying, so this is awesome. Like if you're working on this challenge and you want to ask questions, there's this whole discussion page. I know they also have Discord. I'm an old fogey, so I feel like Discord kind of slows me down. Like I get confused on it and it's like too much to keep track of. So just posting questions here works, but you can just do that by, posting a new topic, asking a question. You can team up with other people. That's cool. Discord's here. Yeah. Okay. So let's just maybe start with the Tunix docs. And understand a little bit about it. And while that's up, we can go to this discussion where there's that 3 billion, Gemma 3, 1 billion parameter model tuning example. Vamsi, good to see you as well. Thanks for hanging out here today. All right, hopefully you guys can see this. This is the notebook that they have as an example to train GRPO, which is Group Relative Policy Optimization. It's like the latest state of the art for doing reinforcement learning on large language models to tune them to be better at things like reasoning, which this challenge has to do with, or for like achieving specific tasks like math and stuff like that. So it looks like this example notebook does go through the reasoning benchmark. Let's go ahead and copy and edit this. That way we can start running the code ourselves. Let's rename this something prettier. So this is Gemma 3 1 billion parameter. Let's see, the real question is, can we get can we get a TPU? Secret attached. The original notebook has a secret. Okay, I think that's going to be our Hugging Face secret. But yeah, so TPUs are popular. I'm number 2 in the queue, so I'm going to have to wait for a TPU. Now, an alternative way of doing this might be just to download this notebook for now. We'll let this run, but I'm going to download this notebook and also get a collab session up. This is like the old notebook where, okay, this is a intro. I'm going to do upload notebook, and then let's go to pull this notebook that we just downloaded into here. Not sure if this will work end to end. So there are different types of TPUs. Remember, this challenge does require that you train on TPUs, which, I mean, that's why you would use JAX, because it's so fast on TPUs. They're using the V5E, so that's the 5th generation of the TPUs, not the latest. And then there's a newer generation that's supposed to come out soon. And -8 means that there are 8 actual chips. So if you look at TPUs, it's kind of like a grid. You could think of it like a Lego piece, like the number of chips in it. You can choose the size and the actual orientation of how you want them, like a 1x2, or you can have a 2x2, or it could be like a 2x4, which could be this 8 chip. Okay, so we're gonna run that chip. Let's see if we actually got one here. So actually we might not need to do this on here, because we did get, even though we're second in the queue, now we're in. So if we go into our resources though, we do that here. Things have changed a little bit since I've last done this. Okay, so this doesn't have resource session options. Okay, yeah, here. V5E-8 TPU. Now, like they said, we have a limited amount of time each month that we can run on this. So it does say a question mark for TPU, but I think we're good. So let's try to run this. I wonder if it has TPU info, which I do like because it'll list out. Okay, that's not a good sign. Now we need to install all these libraries. So what are we installing? I'm going to add -Q to make this quiet. TensorFlow datasets, TensorBoard, transformers, Grain. Grain is like the in the JAX ecosystem, the data loaders sort of library. And then these are commented out. That's Tunix. Wonder why Tunix is commented out. And then it's installing the datasets library from Hugging Face and weights and biases, which can be used to visualize the training run, the loss, and all that stuff as it goes. Do you need a powerful GPU to participate in Kaggle competitions? So having, in most Kaggle competitions, Andrew, you need some sort of powerful resources. It could be a GPU, it could be a TPU. Now in this competition specifically, you need to run on a TPU, which is Google's chip for running machine learning sort of stuff. So in this one, it is definitely a requirement. Okay, so weights and biases API key. This is what we need to visualize this project. So in a new tab, I'm going to open my weights and biases account. And I'm guessing this is just kind of optional. But there is in Kaggle these secrets. I do have it. Oh, it's called W&B. I wonder if that one still works. So maybe since I already have that saved, I can just pull from that. Does not have access to that secret, so it's going to attach it now. Okay, so now I think I have my... Looks like I have my weights and biases key all set up. And then let's see what we're importing. We're importing a lot from Tunix. Let's see. I'm just surprised because we didn't install Tunix here. Maybe that's because they were working on this notebook before the release. Then we can print the version. All right, 0.1.3. If we go to the Tunix repo, we can see the latest release to make sure we have 0.1.3 is the latest release. So that's a good sign. And then it looks like this is just importing a lot of stuff. We have, this cluster, GRPO learner. I believe this is like the heart and soul of running GRPO on Tunix. Also going to put this weights and biases tab here. So this is what I actually looked at this earlier. This was one of the outputs of this example notebook. So this is what our weights and biases page is going to look like when we're done running this. All right, hyperparameters. So let's just define the configuration we're going to use. Note that this no by means perfect set of hyperparameters. So data set, LoRa. So LoRa is, this is when we're tuning this model, even though it's a relatively small model, we don't actually want to tune all the weights of the model at the same time. It's like too much to do for our little training run. Remember, this model is, even though it's 1 billion parameters, it's been trained on a lot of data. And a more efficient way for us to fine tune it is actually to have these lower rank weights that kind of sit outside of the main weights, but still have influence on them, and then tell our model when we're training it only to fine tune those weights. So I'm not quite sure what these parameters set, but definitely something we'd want to learn more about. Sharding. So this is how we split the model across those different chips. And then we have GRPO settings, max prompt length, total generation steps, temperature, top P, and top K. So this is when we're generating responses, and then we're using reinforcement learning to essentially like rank those outputs. We want the model to kind of be more wild in what it's generating so that we get a more understanding of the different result space that we could grade across. So that's why they're saying to keep the temperature high for this, heat it up. Number of generations. So this means for every question in a training step, it's going to, I believe this means it's going to generate 4 answers, and then it's going to use GRPO optimization across those. Number of iterations per batch. Beta, this coefficient for KL divergence penalty in the GRPO loss function, important to keep that high enough value for this, otherwise KL divergence can increase unchecked. All right, we're gonna have to learn about that. Epsilon, this is usually, this is a clipping. So it's pretty common in optimizations to like not overreact to to something that might really sway your optimization based on one result. So you kind of like clip the results so it's all within a reasonable scale to optimize against. Hopefully I'm explaining that okay. Train micro batch size, number of batches. So this is just like how the training is set up. All right, so we can see this, like the number of training steps, I'm gonna guess an epoch is gonna be number of batches. So I wonder how they chose that. Maybe on the input data. We have this grade school math. What size is this? Let's actually go to this page. (1,319) unique values. So this data set in the training set, that's the test set. The training set has 7,473 different examples. So I'm not sure where they get the 3,000 from. Maybe they just chose that. Keep number of test batches low so that runs quickly. Maybe they're only training on a subset of this and then they do evaluation. We'll see. Number of test batches 100. Eval every n steps. And that gives us our max steps. So yeah. All right, learning rate. If you know anything about learning rate, it's very important, or it can be important when you're training models to kind of like ramp up or ramp down how much changes you're gonna let the model weights adjust to each iteration. So this cosine schedule Atom W, yeah, so Atom W is the optimizer. It's always good to, I feel like having these images of learning rate schedules is helpful because then you can kind of see like the different ways people use learning rate. So you could think of this y-axis here as being the learning rate. So like a high learning rate means that it's really going to update the weights a lot every time, every iteration. And then a lower one means like it's barely going to change what the outputs are in the model or how the model weights adjust each step. So this is like a common technique. You have this ramp up at the very beginning where you don't want to start very high. You want to slowly, not slowly, like initially go ramp up to a decent learning rate that you'll start at. And then over time, as you're training, you're kind of like landing a plane. Like you don't want this to go down too fast because then it's not actually going to learn enough. You also don't want it to stay up here with such a high learning rate at the start because it's going to never actually settle on good weights that you're going to end up with. It's going to be kind of more, I guess, wild changes in the results each iteration up here. So you kind of have this like warm-up step and then this cosine learning rate. I've trained models where, yeah, you just have like a cosine, a cyclic cosine where you're just training like this over time. There's also technique where you have this like warm-up and then cosine learning rate, and then you reset and you do it again, and you actually change the width of these this cosine function every time you reset. So it's like you're slowly becoming longer, shorter number of iterations. But yeah, hopefully that makes sense. Do you plan one day on training new data scientists directly? On which models is the cosine annealing really useful? So the learning rate stuff is always a little bit of like from experience, but also it depends on the model size. But typically, yeah, this, regardless of the model, as long as you have a good learning rate values that you're starting with, this is like a good technique. This warm up with cosine schedule. All right, so generation configs, greedy, standard, liberal. Okay, so these are different, for inference, the different type of models that are going to be producing results that we're using for the reinforcement learning. Okay, this show HBM usage. This is going to display of these different chips that we have in our TPU. It's just a helper function for printing out how much memory is being used. Data preprocessing. So here is where we define these special tokens. Remember, the challenge requires that your model is trained to produce these reasoning, text, and then the final answer. So let's define some special tokens. We instruct the model to first reason between these. After reasoning, we expect it to provide the answer between the answer tokens. Our system prompt is you are given a problem, think about the problem and provide reasoning. Place it between this reasoning and provide the answer between these. And then we have our template. So the actual system prompt looks like this. It actually puts in this reasoning tags and what now. Now we're using this GSM8K, which comprises high school math problems. So this looks like some regex-ish formatting of this data set. Downloading the Kaggle data set, getting the data set. These are just helper functions for the data set. And this is where we're actually creating the data set we're training on. So remember, we can see the raw data here. Can I make this bigger? It's kind of hard to see here, but maybe if we just read it with like pandas or something. CSV, I believe. Input. All right, so this is the folder name. Socratic test. All right, let's just look at the main data. So this. All right, so here we have an example of the training data, the raw training data, right? We have this question and then the answer. The answer is the correct answer, I'm assuming. Thought this was Rocket League because the RL, can you tell me what you're programming? We're doing reinforcement learning. I'm only 11. Oh, you're in the right place. Just come and learn. Natalia sold clips to 48 of her friends in April, and then she sold half as many chips in May. How many clips did Natalia sell together in May? That's the question and then the answer. I think this will have the reasoning in it. So here's the reasoning part. If we actually print this, look at the new line characters. So this is how the raw data set is formatted. It has this reasoning part, and then it looks like it does these hashes, and then it gives the answer. So I believe what this, and this would, if you're training on a specific data set for this competition, you're going to have to write whatever sort of helper functions that you'll need for that specific data set, because maybe it's formatted differently. But you can see here, this is getting the answer by splitting the text on those hashes and then stripping all the text around here. So if we did, for this answer, if we did split this on these hashes, we can see now we have a list, which the first one is the question, the second one's the answer, and then they're doing this, which makes it just the answer. So that's just some helper functions for splitting that out. And then we could see that, yeah, the actual data set, it's kind of easy to understand how this works because you have this format that templates the prompts. We use that template from above. We have this that pulls out the question portion and then the answer. Where's the... Okay, so yeah, that's the answer, extract hash answer. So this doesn't actually keep that reasoning part in it. So I believe we have this data set. Oh, that's the get data set function. So we'll have to call get data set to get it. All right, so we're gonna pull this data set from Hugging Face. It's just training function. Okay, and then they're going to go through here and go through one batch of training data. So yeah, it's a lot to read here. We have, this is one element in the batch. And if we go to answer, the way this is formatted is you actually have for the questions and for the answers, they're all put together in an array. So you don't, when you're training the model or you're fine tuning the model, you don't want to have the data in like question answers paired together in a list and then a long list of that for the batch. You actually split these out to like the an array of the questions, an array of the answers. So that's why if we go to this one element, it looks a little bit weird that we have just random numbers here, but these are associated with these prompts / questions. And the prompts, if we look at the first one, I don't know if we can print this. Yeah, so in the prompts, if you remember, this is the formatting that we set way up here. So let's say you're doing this on your own data set that isn't this math problem. You're going to need to change the way this template works because it might not be a math problem and you might need to provide it in a different way. So starting the user turn, we're seeing the user has the system prompt, then we're adding in the question, and then we're seeing it's the start of the model's turn. So this is like priming the model to provide the answer with the correct tokens and all that formatting. So we're telling the model how to format its output. All right, so here you can see this first question formatted correctly. You're given the problem. We're telling it to use the reasoning and the answer tags. Maria has 4 dimes, and then it's like another question. The answer to this one's going to be 3. Now, why isn't this the first value? Like if we looked at that data set, the first value, I'm assuming that's because there's some sort of randomness built into this data set, and that's pretty common too. Yeah, so you have this shuffling. You put a seed in it, but this ensures that the data set isn't just going through in the order that it's provided. And sometimes you even do random shuffling per batch because you don't want those batches that have the same order every time, or else the model could potentially just overfit to that. Okay, so we have an example of the prompt. Does that make sense to everyone? Then we have an example of the answers. The batch size here is just 4. Let's see where the batch size is set. Oh, the micro batch size is 4. Okay. We got through the data part. Load the policy model and the reference model. Okay, so we have two different models. We have the model that we're fine tuning. That's the policy model. The policy model is going to have those LoRa weights updated. The reference model, that's going to be the one we compute KL divergence with. I think that's the grading model. This is to ensure that the policy updates are not huge and it does not deviate too much from the reference model. Okay. Typically, the reference model is the single base model, and the policy model is the same base model, but with LoRa parameters. Only the LoRa parameters are updated. So even though we have two different versions of this model that we're using, we want to make sure they're the same model. Okay, so, and then it's also saying we're using full precision. So the precision of the model's weight, the floating point 32 precision here, means that the model's going to be a lot more, I mean, like, it's kind of like the resolution in your TV screen. Like the size might be the same, but if you have more pixels in there, you get more resolution. Same thing with floating point precision. So full precision is going to be like really detailed. But what they've found is when you're training models, a lot of times you can reduce this precision by making it quantized, and training can go a lot faster because of that. And actually the trade-off of that extra like detail that you can't even see isn't that big of a deal. This is like distilling teacher and student training, sort of. Yeah. Well, there's also this like reinforcement learning component where you're making the model produce a bunch of different potential answers, then you're grading it, and then it's learning. It's not only learning like straight up fine tuning of the model, where you're just providing it all the answers and you're tuning on that. Like if we just tuned on this data set with the questions and answers, we could tune LoRa weights to do that. But a better way to do that is using this optimization process where the heck am I? This optimization process where you're actually producing a bunch of different answers and then it's learning like what the best one is. All right, so now we have to create an API token from your Kaggle settings page and paste it below along with your username. What is this for? Oh, this is to get the model, I think. Okay. What's mine? Rob X cube. I might create a token that I'll have to delete here in a second. My profile settings, going into create new token. It's gonna delete my old key. That's fine. All right, so as soon as we're done here, I'm gonna change this token again. Oh, you don't even see it, so it's fine. All right, my credentials are validated. Now we need to download the model, Gemma 3 model weights. So it's deleting all the previous checkpoints. This stuff should be empty anyways. CodeSnippet serves as a workaround to resave the pre-trained model checkpoint from Kaggle to a local format that is compatible with the Flax NNX library because the original checkpoint has parameter names and tensor structures that don't match the target NNX model architecture. It cannot be loaded directly. We first load the original weights into a temporary model instance, then extract and resave the model state into a new properly formatted local checkpoint. Okay, so it's cool that they give us this. This is basically, it seems like this is code that we can just, whoever you are, or whatever you're doing for your submission to this, you're going to be using this code. And I believe they have it also for the Gemma 2 model. Model loading and LoRa application. These two functions work together to load a base model checkpoint and apply a LoRa layer to it. So this is sort of like the LoRa, what I was talking about before, where it's adding these other weights that sit alongside of the base model. And these are the weights that we're actually going to be training. Get ref model, get LoRa model. So I think what it's doing is some sort of model surgery where it'll define that new model and then kind of paste in the weights of the existing Gemma model. But let's see here. Get LoRa model. Okay, so they do have this NNX display, which I think will let us see what the model looks like. This is the policy model. Remember, the policy model is the model that we're actually going to be updating weights on. Yeah, so we have these different blocks. We can copy the path, but I don't think we care too much about this. Here's the whole config for the model. 26 layers. That's the size of the embedding layers. Do we see LoRa defined here? Yeah, so not going to get too into the weeds with that. Hopefully I didn't ruin my session by loading that, because it looks to be freezing now. Maybe just to be safe, let's comment that out. All right, define a rewards function. So this is where the fun part is. We're actually going to be defining how the model determines how to score the answer that it's producing. So this is how, like, the crux of how the reinforcement learning is going to work. So their example consists of 4 reward functions. If we're creating our own, we're going to want to make them specific to whatever we're working on. But if the format of the output exactly matches the instruction given in template. Okay, so we're grading it. And if it doesn't even use the correct formatting with these answer and reasoning tags, then we're going to dock it for doing that. Hey, Samula, welcome from Hyderabad. Glad you're here. So that's one of the 4. Reward if the format of the output approximately matches. Okay, so this is all just formatting stuff. Reward the answer is correct / partially correct. Sometimes the text between answer might not be one number. So we extract the number and reward the model if the answer is correct. Okay, we're going to have to see how that works. The reward functions are inspired from here. So here's a demo where someone created similar rewards. Okay, so this is just a regex string that's checking to see if it matches the format. It's searching for that. Okay, so this regex is just a definition of it'll give true or false, I believe. Oh no, it'll respond with the span if it matches this reasoning and answer. Reasoning and what is this? Give the model 3 points if the format matches exactly. So this is a pretty easy function. It's just seeing if the response exactly is in the format. Second time chatter here. Hey, welcome. This is an approximate score. So how does this work? Also reward a model if the format output matches partially. So it's giving half a point if it has this reasoning start and end, each in the solution start and end. Response equals completion for completion and completions. All right, so it looks like it's giving, depending on if it has that start and end tag, it'll either give plus 0.5 points or negative. Reward the model if the answer is correct. All right, we're not going to go through this, but maybe we'll do some examples. Sometimes text between the answer might not be one number. It can be a sentence. So they extract the number and compare the number. So this is just some regex to pull out the number found in it. So you can see this text, if we put like any non-numerical value in here, it's going to just pull out the numeric value. If this numerical value is different, it's still going to pull that out completely. What if there's like a 11 here? Well, then it just pulls the first one. Makes sense. So these are all like the things we're using to judge the model's output. All right, check numbers. So evaluate. Before we train the model, let's evaluate the model on the test set so we can see the improvement. So this is like setting a baseline here for how well the model does. Answer accuracy, partial accuracy, format accuracy. So this model might actually just even struggle at the beginning to use that slash answer tag and the thinking tag or the reasoning tag. I want to kind of score this, see how the scoring works. So yeah, let's not get hung up on this too much. This is just generating all the answers from the model. This is the evaluation function. Generates responses. Where does it actually grade it? Correct counter per question, partially correct. This is where it checks the format. I kind of wish all the scoring, like the reward functions were all put in their own function. So I could just run it on an example text and we could see the answer. But I guess what we're doing here is we're just going to be able to visualize that here. Okay, so this says it's going to take a while to run because it's going to run through all of the test set, send it through the model, and then produce these final stats, right? I don't want to run that right now. If I just do, can I slice on this? So if I do the length of this test data set, it should be a couple thousand. Oh, it's only 100. Is that because it's batched? Let's look at the first one. Yeah, so it's 100 times 4 because it's 4 in each batch. But if I just run this on the first one, then we won't have to wait all those minutes for this to run. Maybe it still will take a while. One thing we can look at now is it's using a lot of CPU, but it should also be leveraging this TPU. All right, so only ran for one of those batches. 25% had partial accuracy. I actually want to see like how it computes this for each one. Let's just for fun here, take this evaluate function and just and below here, we're just going to do like our own print the results as we evaluate. And this is just for our own understanding. So I'm going to make this evaluate function called evaluate verbose. And then I want to actually see what the results look like. So this doesn't like it's two spaces indentation. This is going to be, so we're going to say question is this question, right? Answer. So we'll just print this out. This is extracting the responses. And then we're going to do, this is iterating over all the responses. Response. And then we'll have something to track which response number this is. And at the end here, we'll also increment. I cannot understand the indentations here, but let's just do I plus 1. Get the extracted response. Okay, so we should actually do this extracted response here. And then we're going to go here and just say print correct. This is going to be a correct answer or correct response plus 1. Check format. And this is going to be correct format plus 1. And then we're going to say partially correct. And this could be the amount. And this is going to be correct format. This is going to help us visualize the how the scoring's working. Hopefully, if I did this right. Don't want like that. All right. Anyone else? Anyone still with me? And then this is our total. We don't care about that. Because what this is doing is it's grading everything. It's not really showing us what's going on under the hood, like how each of the grades comes in. It would, and I want to see like not the final statistics of how well the model did, but I want to actually see how well is the model doing at each of these parts of the reward function. So I'm just making a verbose evaluation function that prints it out, which isn't the best way to do it. It would be nice if I could run the evaluation and have a data set that actually shows the different areas. Because at least with Kaggle competitions in the past, it's very important to understand not only like the final number of any evaluation metric, but the components that make up that. And if what you find is that the model is never actually formatting it even partially correct, then you can kind of hone in on why it might be failing with that and try to improve it, as opposed to like blindly not being sure why the model's never producing things right. Or if it like is constantly making a mistake with the formatting, then maybe that system prompt that they're using could be improved. So let's see if we can just visualize this. Hopefully this works. We're going to change this for the verbose version. All right, so now we actually have printed out the question, the answer from the model, and then this is the question from the data set. This is the correct answer. And then we're going to have 4 responses, I believe, because we have a micro batch of 4 for each of the questions that it's generating, this generator model. So here's the reasoning section. Here's the answer. So this is correct. The extracted response is correct. It's correct format. It's partially correct, and it has the correct format. So I think the second one's like the correct format of the whole thing. Here's another question. Let's see if any of them do not get the correct format. Okay, so the answer to this one is wrong. The correct answer would be 450. And it's giving the answer of 153. So we could see that this answer did not get the correct format for the answer, or correct response. So yeah, that just gives us a little bit more insight into what's going on under the hood. Because I think actually like looking at these can help you form your opinion of how to improve the model. All right, let's just continue on. Then we'll close out here, but let's actually get this training started. So checkpoint saving. This is how we're going to save those weights. Metrics logger. Okay, so this is saving a TensorBoard. We have our optimizer. We're using Atom W with all those parameters that we had talked about before for the learning rate scheduler. Here's all the configuration for the training. So the nice part is that this is like this R1 cluster lib is all just coming from Tunix. So it's handling all this reinforcement learning, clustering. It has this GRPO learner, where if we actually look into that, see if we can find it on GitHub here. Yeah, so like this loss function has everything that's needed for running GRPO. We don't have to code this manually. We can kind of just leverage what's already here. It's written in JAX. It's going to be very efficient. It's just great that this already has it all set up. And then like we can set our config parameters here. We can adjust those. We don't have to really mess around with more on our own. So this is our configuration that we're setting up. GRPO config. Basically just loading in all that stuff from that config cell that we had higher up in this. Now we initialize our system for training. First, we create an RL cluster instance, which brings together the policy model and the reference model. The reference model is the one we're updating weights of, and a tokenizer. Our actor is a trainable LoRa model, while the reference is a fixed base model. Okay, so I had that backwards. The actor is the one we're updating. That's the policy model. We then create a GRPO learner. The specialized trainer uses a list of reward functions to evaluate. If you're running a quick experiment, that's what we're doing here. Choose this. Okay, so Tunix trainers are integrated with weights and biases. That's nice. So we can visualize it as we go. So this can create a temporary private dashboard. That's fine. Let's get this RL cluster and let's get this trainer. What's it complaining about? Perfect. It's complaining because there's no internet. And by default, oh, it says the internet is on. Yeah, so it is able to access the internet. I think it might be that my weights and biases token is outdated. So let's see where it does that. Init cluster. Cluster config. Might need to fix that later, but we do need this RL cluster to work. Where else is the weights and biases set? Let's see if I can initialize it here. It's going to complain. Oh, so this is actually an issue with the weights and biases module. This doesn't have to do with anything in our code. Someone's already mentioned this. This is old though. We're debugging. Version incompatibility between the weights and biases and dependent library. Ooh, look, this is someone saying there's a bug in Kaggle notebooks. So it says to fix this, we install the latest development version of weights and biases. Go back to our demo. Where's that? Oh, it's here. I believe we did install. Weights and biases here, but let's do what they suggest and upgrade with maybe the pre-release version. .23.0. .23.0. It came out 20 hours ago. This is a common issue. Maybe this latest release is the problem just because it came out so recently. Maybe we can force it to use this 22.03 and might get lucky. So this notebook, when it was created, it was created probably with this 22.3 version. So it's saying, oh, W&B. So now it's uninstalling 23.2 version. Don't know if this will work. But when major releases come out, can produce breaking changes. Yeah, so we're actually like downgrading weights and biases. Get back to where it failed. Might have to restart this. Restart this session. Which is fine. I don't think anything we did here took too long, right? And I wonder if there's a way just to disable weights and biases. We're installing all this stuff. We're seeing our weights and biases version. Oh. Then we're gonna, okay, so this did do 22.3. Okay. Let's see if this works. Run all of our code. It doesn't like jump to the right location anymore. Do I need to log in again? Don't have my Kaggle key. Paste this here. Move all this temporary stuff. Params not defined. It's fine. It's trying to delete something that doesn't exist. See how much space we have on disk. Might need to restart this from scratch. All this to be said, I think we're going to end here soon anyways. But let's just go over to the actual version that ran end to end. Oh, we can also see here what version of weights and biases was installed, I believe. Go to the top here. Wow, it says weights and biases a lot because it looks like in the logs when it prints it out, it says weights and biases every time. Installing Tunix. Installing Flax. Yeah, it looks like it doesn't print the version. But let's see what it looked like when they loaded the model, defined the reward function, evaluate, and then train. We were right at the end. So they ran the training configs, set up the GRPO trainer like we were. They were able to log in. This is where ours failed. It says it uses 22.3. And we can see their run results. So this is the cool part. When we run our training, let's say we created a data set that was like, instead of being math problems was something like crossword problems or Wordle or something like that. Like, and it had its explanations. Then we'd create our own reward functions. We'd run this, and then we'd be able to view how well the model is doing against the reward as it trains. So this is pretty cool to see all the different runs that they had. And you could see like the reward function is getting better. Hit Mitch Sue's leaving. Yeah, thanks for hanging out. Yeah, so we could see things are improving as it's training. If we were running this live, we would actually see this going throughout the process. You can view each run is going to be a different example in weights and biases. And then you can kind of hone in on, if you're training to a point and it's reaching a threshold that's not really getting better then, and you know when to stop and to start thinking of better ways to do the training. But it looks like that's it. So then you have the model, and I'm assuming they run evaluation on the trained model, and then you see like the metrics of how well it improved it out. All right, so maybe next time we can try to do, I could get this working end to end, and we could try to do maybe a unique type of problem that will fine tune the model using reinforcement learning on, and not just this math stuff. But I hope that was helpful for everyone who hung out. This challenge is going right now. It's 2 months till it ends. Perfect time to jump in because it's just brand new. And yeah, you can have a chance to win part of that $100,000 cash prize. So check that out. Make sure you give this a thumbs up on YouTube if you enjoyed it. And I will see you guys next time I stream. Thanks a lot. I really appreciate it.